Welcome to lecture 21, 8051 interrupts programming using embedded C. 8051 consists of 5 interrupts: external hardware interrupt 0, external hardware interrupt 1, timer 0 interrupt, timer 1 interrupt, and serial communication interrupt. In this lecture, we are going to discuss external hardware interrupt. It consists of the two interrupts. One is external hardware interrupt 0, another one is 1. So we are going to be generate the interrupt with the help of external the pin of 8051 microcontroller. You can look at here, this is a port 2 pin configuration. It consists of RxD, TXD, INT0, INT1, T0, T1, WR and RD. So port number 3 we can use it for a simple input and output operation as well as some alternate function like this. So with the help of P3.2 we can generate the external hardware interrupt 0. With the help of P3.3 we can able to generate the external hardware interrupt 1. Just you can look at this diagram. This is a physical pin of 8051 pin 3.2. So in pin 3.2 you have to be give the inputs like clock source. The clock source may be edge triggered or level trigger. Based on the edge trigger and the level trigger, the interrupt is going to be invoked. So here there is a pin, not a pin. This is a bit IT0. It is available in the timer control register. This is a timer control register. It is a 8-bit. The upper 4 byte already we discussed for timer programming. This lower 4 bytes it is purely relating to this external hardware interrupt. So these 4 bits we are not going to be use it for timer interrupt as well as serial communication interrupt. These 4 bits only we can using for this external hardware interrupts. So here you see IT0, it is related to the external hardware interrupt 0. IT1 it is external hardware interrupt 1. Same like IE0 for this interrupt and IE1 for this external hardware interrupt 0. So this is the internal the diagram. Suppose if you are connecting any the pulse or clock whatever maybe you have to be connecting the pin number 3.2. So the inside the pin configuration is like this. So the IT0 you can configure with the help of this timer control register. Suppose you are giving the level trigger, no need to configure any of the register, any of the bit is going to be set. So suppose you are going to be use this edge trigger, so you can make it configure this IT0 pin as 1. The same applicable for this external hardware interrupt 1 also. If you want to make this pin number 3.3 the input you are giving edge trigger, you can make this IT1 is equal to 1. IT1 is equal to 0, it is a level trigger. IT1 is equal to 1, it is a edge trigger. So what is level trigger, what is the edge trigger, we'll see. IT not equal to 1 when the edge trigger is going to be appear in the pin number P3.2. For example, how the pin P3.2 it will recognize as the edge triggering. For example, one machine cycle high, one machine cycle off, then the pin number 3.2 will recognize as it is an edge trigger. You have to be make this IT0 bit is equal to 1, one machine cycle high, one machine cycle low, then this P3.2 pin recognized as the edge trigger. Once this edge trigger, once it is detected by the pin number 3.2, the IE0 bit is going to be 1. If it is 1, the interrupt is invoked. Once interrupt is invoked, it goes to the main program. What is that? The microcontroller execute the main program. Suppose any interrupt invoke, what happened? The microcontroller immediately stop the current program. It goes to this memory location 003. So in this memory location only we write the interrupt program For external hardware interrupt 0. Whatever the program you written over there, it will execute it. Once it will complete this execution of this program, again come back to the main program. So this is a process. So this is related to edge trigger, one machine cycle high, one machine cycle low. The next trigger, the next interrupt you want to invoke, again the one machine cycle high, one machine cycle low, then next interrupt is going to be invoked. That is in case of edge trigger. For example, in case of level trigger, one machine cycle high, 4 machine cycle low, then only the pin number 3.2 recognized as the level trigger, as well as it is going to be invoke the interrupt. Once it will invoke the interrupt, it will directly go to this the interrupt service routine program. It is whatever you written over there, it is going to be execute. For level trigger, this IE0 pin is not going to be enabled over here. Only edge trigger, IE0 is 1, then the interrupt is invoked. Here the level trigger, if you are the input, the clock, if it is a 4 machine cycle, it is low, then the interrupt is going to be invoked and directly go for this ISR program. The same procedure for the external hardware interrupt 1, the same IT1, IE1, and the address for the ISR for this external hardware interrupt 1, it is 0010. Here they used to be write the program. So with the help of physical pin 3.2, 3.3, it is available outside the 8051 microcontroller. That's why we can call this interrupt as external hardware interrupt. So the TCON register, it is a timer control register. Here if you want to configure whether it is a level trigger or edge trigger, with the help of IT0 and the IT1, you make this bit as 1. Suppose if you want the level trigger input, if it is 0, if it is 0, it is a level trigger. If you want edge trigger, you make this IT0 and IT1 as 1, then the pin, the corresponding pin recognized as the edge trigger input. Once edge trigger input is recognized, the interrupt is going to be invoked. Before that, this IE0 bit is going to be set. This IE0 bit is going to be set. After that, the interrupt is going to be invoked. Fine. Now IE, it is an interrupt enabled. It is very important one. Already you know the 8051 interrupt is the maskable interrupt, as well as you can enable or disable. So which interrupt you want, make that particular bit as 1, so that interrupt is going to be enabled, as well as you make this EA, enable access. This is what is that global enable. You have to be make it this high. If it is 0, even though you can enable any one of the interrupt, the interrupt is going to be generated because you made this pin as 0. If you want to any one of the bit, you make it to high to what is the generate the interrupt, you must enable this pin as high, then only the interrupt is going to be invoked. The next, in this example, we will use both the interrupts. One is external hardware interrupt INT0 and INT1. It is a pin number they given. The low signal on these pins will generate the corresponding interrupt, causing it to execute the respective ISR. It is an interrupt service routine. INT0 ISR will increment a counter, whereas INT1 will decrement as a same counter. This is INT0, this is INT1. The main program will just display the 8-bit interrupt counter on LEDs connected to P0. Okay, now I am going to the program to be able to understand. So interrupt, so as already we discussed, if it is the interrupt is generated, the program is go to the controller is going to execute whatever the program written over here, that is 0003 location only. The program will return if the external hardware interrupt is generated. But this is in case of assembly level programming. But in case of embedded C, so for each interrupt they specified with the name, that is interrupt 0 means the external hardware interrupt is 0, external hardware interrupt 1 means it is interrupt 2 and so on. So here we focus interrupt 0 and interrupt 2. Just we come for the main program. It is the header file as defined LED SP0. I want to access all the pins of P0. So P0 is assigned with some other name LED S. So unsigned character count is equal to 0. Why? Because usually you have a practice to write embedded C programming for 8051 microcontroller. Please use this unsigned char or signed character. Don't use the unsigned int or signed int. Why? Because the unsigned character and signed character, it is a 8-bit. So it occupies only 1 byte memory space in the program memory. Suppose you are using unsigned int or signed int, okay, it occupies a 2 byte in the program memory. So you have a practice to write with that signed int and unsigned int. You are going to be lost the 8051 memory space. Already in our 8051 microcontroller, if having just 4K of RAM, what is that, ROM, 4K program memory only we are having. So don't waste unnecessarily, or is that you choosing the data type like unsigned int and signed int. Better for 8051 the regular practice to use unsigned character. That is very important to what is that consume memory space. So okay, initially count is equal to 0. Void external some name, whatever the name you want, you can give over here with the function. Okay, this is what is that user defined function only. Here it is a ISR, that's why you must represented here as interrupt 0. So then only if any interrupt occur related to the INT0, so the directly the main program is come over here, it going to be execute. Likewise, it is a interrupt 2. Why? Because the interrupt number in C, it is interrupt 2. That's why I use interrupt 2. Okay, come to the main program. This is very simple program. PCON, it is a control register. I configure with 0x05. Why I used 0x05? Why? Because I am using the edge triggering. So 1, 1. Because of edge triggering, I configured with 0, 5. And IE, where global enable you should make it to 1, and I am using external hardware interrupt 0 and 1. So that's why external hardware interrupt, this is 1. This is the external hardware interrupt 1. This is external hardware interrupt 0. This is 1. So what is that? 8, 5. You convert it into hexadecimal, you will get fine. So external hardware interrupt 0, external hardware interrupt 1. So both the interrupt I make high, then only you can able to generate the external hardware interrupt 0 and 1, as well as you make this pin as high. Then only you are going to be generate the interrupt and your program is going to be execute the interrupt service routine program, or else it won't work. So the same value 05 and 85 I loaded as TCON 0x05, 0x85, and one important thing, you have to be use IE small x85. So simply you use the 85, it will consider as a decimal number. If it is hexadecimal, there is a procedure to represent as 0x85. So while of 1, it is an infinite loop, LED is equal to count. Already the count is assigned with 0. Whatever the value in the count, it is moved to LEDs. LEDs is nothing but P0. So all the pins of P0, what is that? It will sending zeros. So LEDs is equal to 0. Now, for example, in the physical pin of 8051 microcontroller, if you make 3.2, suppose you generate this edge trigger, or what is that, you can apply this edge trigger, what is that, the IE0, we make it to 1, so interrupt is going to be generate. So the controller is going to be execute this ISR program. Suppose if you are make this edge trigger in the pin 3.3, it is high to low, one machine cycle high, one machine cycle low. So the interrupt is going to be invoked. Whatever the program you written over here, it is going to be execute. Same I done over here. P 3.2, suppose you make high to low, this program will execute. If it is low to high in the pin number P3.3, this interrupt is going to be invoked. For this interrupt, the count value is going to be plus plus. So again, whatever the value in the count, it is displayed on the LEDs. It is automatically, what is that, it comes to this original. Already I told that whatever the flags they related to the interrupts as well as timers, automatically what is that, clear the flag. As a programmer, you no need to, what is that, clear with the help of program. Okay, suppose in the 8051 interrupts, no need to clear any of the flag bits. So again come over here, whatever the value in the count, it is moving to LEDs. Suppose if you are making high to low on the P3.3, again it will go to here, it is going to be minus minus. Earlier the count value is 3. If it is this enable, this interrupt is invoked, it is going to be 3 minus minus means it becomes 2. So now I am going to be demonstrate with the help of Keil software. You can able to understand very clearly how this the interrupt programming is working. Okay, the same already I copy and paste over here. I am going to compile and run. Yeah, 0 errors, 0 warnings. Fine. Now I am going for debug. So now I chosen over here the earlier I taken. Anyway, I close once again. For your benefit, I am going to be interrupt. So this is the interrupt. So having a interrupt 0, timer 0, interrupt 1, timer 1. There is a serial communication, only one. For transmitter as well as receiver, there is a only one interrupt for serial communication. The location is 0023. But in case of embedded C, no need to worry about this, the interrupt vector address. Simply you can use interrupt 0, interrupt 2. The name is sufficient. So we know the global enable, that is EA, IT0, IE0 and EX0. EX0 is external hardware interrupt 0. So now I am going for see the output. I go for port 0. This is the port. I am going to be see the output. Y means LEDs where I connected P0. So count initially 0, or the 0 is moved to LEDs. After that the count, once the interrupt generated, the count is going to be incremented. If it is interrupt 0, that is external hardware interrupt 0, the count is decremented if it is external hardware interrupt 1. So I am in need of one more port, that is a port 3. Port 3 we having, this is P3.2 and P3.3. 3.2 is INT0, hardware interrupt 0. 3.3 means hardware interrupt 1. So 3.3, if it is invoked, what is that? The count is going to be increment. If it is 3.3 is, what is that, high low, that is edge trigger, this value is going to be decrement. So now I am going for stepwise. Now Tcon, here I Tcon, I make it as I made a mistake, it is a 0 0, so I make it to 5 because of edge triggering. After that I will also give the demo. For example, if you are giving the level triggering, what will happen? So I execute this one. So now everything is fine. I am going to run this. So Tcon, the Tcon register is where it is in the timer. Okay, the timer. Here you can see the timer. Okay, Tcon register. But external hardware interrupt programming, the timer is not required. So I want to show the TCON register because lower byte it is purely related to external hardware interrupt. That's why I am using the TCON. Okay, I choose a timer / counter 0, this peripheral. Suppose if it is the lower byte, sorry, higher byte, IE not, this TR not, TF not, it is very important. So that is related to the timer programming. In this juncture, it is not care of this bits. If only focus on this lower 4 bits, that is IT not, IT1, IE not, IE1. Okay, fine. The next IE equal to here. So you see the global enable is tick, IT node is also tick, and EX node is also tick. Because of what is that? With the help of the TCON register, I make this bit as high. With the help of interrupt enable register, I make this high. With the help of EX node, it is nothing but internal what is that? Interrupt enable. You have to be make this enable as, you make this interrupt as enabled. That's why it is a tick mark. So here you can see the interrupt 0 external hardware interrupt mode 1. So this is the both are what is that enabled. So now going for run the entire program. Now initially what happened, the count value initialized with 0. Now whatever the value inside this count, it is moved to LEDs. So LEDs where we connected port 0. So now all the pins are 0. Now I am going to be generate the interrupt with the help of P3.2, that is external hardware interrupt 0. So I just high low, what happened, you see the P0 pin, it is going to be incremented. It goes over here, incremented. Again P3.2, 3, each and every input, every trigger, high low is not required, high low, this is going to be generated. So whenever the interrupt is invoked, this IE0 bit as 1. I already told you, just you can see carefully, high low become. Okay, you see. Okay, 3.3, this is going to be, what is that, high. After that it become automatically the, what is that, the interrupt, all the flags going to be, what is that, become 0. So now I want to decrement. For decrement, I used to use 3.3. So I make it here. So A becomes 9. Again P 3.3, 8, 7, 6, 5, 4, 3. So what is the observation over here? With the help of physical pin available in the 8051 microcontroller P3.1, P3.3, we are going to be generate the interrupt. According to that, it is going to be run the main program. Whenever the interrupt is invoked, it go and run the interrupt program. Run the interrupt program. What is the main program? Whatever the value in the count, that is moving into the LEDs. That is the main program. Here just we configure TCON and IE. We are not going to be used anymore. Once we can initialize, that's it. Whatever the value in the count, it is going to be moving to LED. But this movement of count to LEDs not I written in the what is that interrupt service routine. I written in the main program. Once we execute this ISR, that is the external hardware interrupt program, that is plus, again come over the main program. Whatever the value in the count value, what is incremented, that is moved to LED X. Again you generated one interrupt, again go back to the concern program, add, and again come over here, count value is moved to LED. So I already told that. So I used to give the level trigger. I want to show what will happen. As of now, what we discussed so far, that is related to edge trigger. Okay, high 1 milli machine cycle, low 1 machine cycle. The edge trigger is going to be invoked. When this level trigger is going to be invoked, 1 machine cycle high, 4 machine cycle off. So what will happen? So here I am going to be run entire thing. So nothing here. IT not to equal to 0. What will happen? This is, it is what is that level trigger input. So now I am going for P3.2. So I make it high, so there no interrupt invoked. As already told, you have to be, what is that, invoke the interrupt with the help of 4 machine cycle only. But 4 machine cycle is nothing but 4 microsecond. Okay, so I am going to be on and off. It will take nearly, what is that, 1 second. So compare with 1 second with the 4 microsecond, it very less. That's why once I make it to 0, you see continuously it is going to be incremental. Stop. After that I go for 3.3, so it is automatically going to be decrement. So that is the, what is that, if it is the level trigger. So you have to be give only 4 microsecond only off. If you more than that, you will give again, what is that, next the what is that, interrupt is going to be invoked. The program is going to be run according to which pin you selected over here. P3.3 means the interrupt, hardware interrupt 1, what is that, 3.2 means external hardware interrupt 0. So it had to be taken very seriously, these things. Okay, high low no issue. Even though earlier high low it is going to be one count only going to be increment, but in case of UC, even though I make it high low, it is going to be, what is that, moving fast to, what is that, increment. Okay, so usually we refer only, what is the edge trigger. The level trigger means you have to be precisely, you have to be, what is that, generate the clock source according that clock frequency had to be desired. After that only you can give that the clock source into that pin for level trigger, what is that, interrupt generation. So this is the one drawback. Suppose if it is more than 4 clock cycle, sorry, machine cycle, it is going to be, what is it, automatically the interrupt is going to be again and again it is going to be generated. Okay, thanks for watching.